we continue to look at heat and temperature, and in this lesson we look at temperature scales. Now when we say something is hot or something is cold, how hot or how cold is it, by how much? So we need something to be able to put this concept in numbers, and that thing is what we call a temperature scale. So a temperature scale is simply a way of quantifying temperature. There are two such scales widely used in scientific and everyday work. They are the Celsius scale and the Kelvin or thermodynamic temperature scale. Excuse me. Of course, there is also the Fahrenheit scale, used mostly in the USA. On the Celsius scale, temperatures are measured in degrees Celsius, okay, and on the Kelvin scale, they are measured in Kelvin. Observe that there is no degree symbol here, okay, so we simply write maybe 20 Kelvin. We don't write 20 degree Kelvin. This is wrong. This is wrong. Of course, you can write 20 degrees Celsius, you can write 20 degree Fahrenheit, but not degree Kelvin. The Celsius temperature theta and the Kelvin temperature are related by the equation T equals theta plus 273. This simply means that 0 Kelvin is the same as 273 degree Celsius. So if we have a temperature, let's say 10 degrees Celsius, to convert it to Kelvin, simply say T equals 10 plus 273, and this is equal to 283 Kelvin. Okay, right. Now when you construct a new thermometer, let's say you have just built a mercury in glass thermometer, now this thermometer has just been constructed, it has not been calibrated, there are no marks on it for you to be able to read. So how do we do that? Okay, one way of calibrating thermometers is by using what we call fixed points. Okay, one of those fixed points is a lower, what we call a lower fixed point, which is a temperature of a mixture of water and ice at atmospheric pressure. And we also have an upper fixed point, which is the temperature of a mixture of water and steam atmospheric pressure. So it therefore means that if we construct a new thermometer, we put it in a mixture of water and ice, where the mercury level stop rising, we'll mark that as the lower fixed point and put it in a mixture of water and steam or water vapor, and where the mercury level rises to the maximum, we mark that as the upper fixed point. Now on the Celsius scale, the lower fixed point is 0 degrees Celsius and the upper fixed point is 100 degrees Celsius. When you mark this, the difference, let's say this at this position it is 2 centimeters, and at this position the height is let's say 60 centimeters. The difference between these two is what we call the fundamental interval. The difference between the upper fixed point and the lower fixed point is the fundamental interval. Now when you divide the fundamental interval into 100 equal divisions. So we take this length, the fundamental interval, and divide it into 100 equal divisions. One division is equal to 1 Celsius degree. Now we have taken an example of mercury. It could be for any thermometric property. For example, it could be a resistance of a conductor. It could be the pressure of a fixed mass of gas at constant volume. Now, how do we get a temperature on a thermometric scale using any thermometric property? If you have any thermometric property on the Celsius scale, the temperature is given by this equation here. So where x theta is the value of that property at the temperature we are measuring, x0 is a value of that property at the lower fixed point, and x100 is a value of that property at the upper fixed point. Okay, so if we're using length, change in length, our L here will be length, our x will be length. If we're using resistance, it will be resistance. And if we're using some other thermometric property, it will be that thermometric property. Now let me get back here. The Kelvin scale, or the thermodynamic temperature scale, is based on the concept of absolute zero. Absolute zero. Absolute zero is the temperature at which all motion ceases. So at absolute zero, nothing can move. Okay, all atoms, all molecules stop from moving, they stop vibrating at absolute zero. And on the Kelvin, on the Celsius scale, that temperature is negative 273 degrees Celsius. And on the Kelvin scale, the temperature is taken at 0 Kelvin. So the 0 on the Kelvin scale is the absolute zero. This is why sometimes the Kelvin temperature scale is also known as the absolute temperature scale. Absolute temperature scale. Okay, so reminder, note that absolute zero is the temperature at which motion ceases. A few examples. In an unmarked mercury in glass thermometer, the length of the mercury column when put in pure melting ice is 5 centimeters, and when put in steam the length is 25 centimeters. Given that the length is 20 centimeters at some temperature theta, determine the value of theta. So from this here we can quickly deduce that the value or the length at the lower fixed point x0 is 5 centimeters. The length at the upper fixed point is 25 centimeters. The length at the temperature theta is 20 centimeters. Therefore means that the fundamental interval is 25 minus 20. So the temperature theta be given by x theta minus x0 divided by x 100 minus x 0 times 100 degree Celsius, and this will be equal to 20 minus 5 divided by 25 minus 5 times 100 degrees Celsius. That is equal to 15 divided by 20 times 100 degrees Celsius. If you evaluate that, you see that it is equal to 75 degrees Celsius. Let us look at the second example. A thermometer with no scale is taped to a ruler as shown in the diagram. When in steam, the mercury level rises to 22 centimeters, and when placed in ice, the mercury level falls to 2 centimeters. Which temperature is shown by the mercury level excuse me, in the diagram? Okay, from what has been given here, we can see that the value of the length of the mercury at a lower fixed point is 2 centimeters, and the value at the upper fixed point is 22 centimeters. The value at the temperature theta, which we are looking for, has not been given directly in the equation, but if you look at the diagram, they are approximately 8 centimeters. Therefore, the temperature theta is equal to x theta minus x naught divided by x 100 minus x naught. This is equal to 8 minus 2. This is times 100, of course. This is times 100. Okay. Divided by 22 minus 2 times 100 degrees Celsius, and this is equal to 6 divided by 20 times 100 degrees Celsius. If we evaluate that, that should give us 30 degrees Celsius.